Kabalitan from ACT2, CRT Cabanatuan Branch. My assigned topic is the concept of registers. Before we discuss the way in which the CPU executes instructions, it is necessary to understand the concept of a register. A register is a single permanent storage location within the CPU used for a particular defined purpose. A register is used to hold a binary value temporarily for storage, for manipulation, and for simple calculations. Note that each register is wired within the CPU to perform its specific role. That is unlike memory, where every body address is just like every other address. Each register serves a particular purpose. The register size, the way it is wired, and even the operations that take place in the register reflect the specific functions that the register performs in the computer. Registers also differ from memory in that they are not addressed as a memory location would be, but instead are manipulated directly by the control unit during the execution of instructions. Registers may be as small as a single bit or as wide as several bytes, ranging usually from 1 to 128 bits. Registers are used in many different ways in a computer, depending on the particular use of a register. A register may hold data being processed, an instruction being executed, a memory or input and output address to be accessed, or even special binary codes used for some other purpose. In the CPU, the equivalent to the calculator is known as the accumulator. Modern CPUs provide several accumulators. These are often known as general-purpose registers. Some vendors also refer to general-purpose registers as user-visible or program-visible registers to indicate that they may be accessed by the instructions in user programs. Groups of similar registers are also sometimes referred to collectively as a register file. We have 4 control unit contains several important registers. Number 1, as already noted, the program counter register or PC or IP holds the address of the current instruction being executed. Number 2, the instruction register or IR holds the actual instruction being executed currently by the computer. In the little man computer, this register was not used. The little man himself remembered the instruction he was executing. In a sense, his brain served the function of the instruction register. Number 3, the memory address register or MAR holds the address of a memory location. Number 4, the memory data register or MDR, sometimes known as the memory buffer register, will hold a data value that is being stored to or retrieved from the memory location currently addressed by the memory address register. The control unit will also contain several 1-bit registers, sometimes known as flags, that are used to allow the computer to keep track of special conditions such as arithmetic carry and overflow, power and failure, and internal computer error. Usually, several flags are grouped into 1 or more status registers. 4 primary types of operations most registers support. Number 1, registers can be loaded with values from other locations, in particular from other registers or from memory locations. This operation destroys the previous value stored in the destination register, but the source register or memory location remains unchanged. Number 2, data from another location can be added to or subtracted from the value previously stored in a register, leaving the sum of difference in the register. Number 3, data in a register can be shifted or rotated right or left by 1 or more bits. This operation is important in the implementation of multiplication and division. Number 4, the value of data in a register can be tested for certain conditions such as 0, positive, negative, or too large to fit in the register.
Hi, good day. I'm Percival G. Calano Jr., ACT2, and my topic for today is related to characteristics of a buses. What is a bus? A bus is characterized by the amount of information that can be transmitted at once. These amounts, expressed in bits, correspond to the number of physical lines over which data is sent simultaneously. A 32-wire ribbon cable can be transmit 32 bits in parallel. Typical ports on a personal computer might include USB ports, network ports, and display port or HDMI ports. Both the CPU and memory would have to agree. For example, that particular line is mean memory read, and an 1 on the line means memory write. Buses are used most commonly for transferring data between computer peripherals and the CPU, for transferring data between the CPU and memory, and for transferring data between different points within the CPU. The electrical conductors may be wires, or they may be conductors within integrated circuit or on a printed circuit. Optical conductors can carry data much faster than electrical conductors, but their cost is high, which has limited their use to date. Especially, a bus may be defined as a group of electrical or less commonly optical conductors suitable for carrying computer signals. Optical conductors work similarly, using light that is direct from the point to point in special thin clear glass fibers. There are no separate address lines in a serial bus. A bus line may pass data in one direction only, or may be used to pass data in both directions. Indeed, with advance in serial bus technology, serial buses are now preferred for most applications, even for those requiring high data transfer rates. The physical connection that makes it possible to transfer data from one location, the computer system, to another is called a bus. Data lines carry the data that is being moved from one location to another. Buses that are indeed for more general use must have a well-defined standard. Standard buses generally have a name. Generally, a serial bus has a single data line pair and perhaps a few control lines. A bus that carries signal from a single specific source to a single specific destination is identified as a point-to-point bus. Although you might think that the throughput of a serial bus would be lower than a parallel bus, theoretically capable of the same per line transfer rate. The limitations noted above make serial bus transmission attractive in most circumstances. Such a bus is known as a multi-point bus, or sometimes a multi-drop bus. For simultaneous two-way communication, a second data line pair can be added. Data moves between the various modules, memory, and the CPU in similar fashion. Parallel buses are expensive and consume a considerable amount of space. A bus might be a tiny fraction of a millimeter long, carrying data between various parts of the CPU with an integrated circuit chip. It might be a few millimeters long, carrying data between the CPU chip and memory. It might even be several feet long, carrying data between a computer and a printer or monitor, or between different computers. In the simplest case, each line carries a single electrical signal. Thank you.
Unit. Operation of memory, memory capacity and addressing limitation. Primary memory characteristic and implementation, the fetch execute instruction cycle. The operation of memory. To grasp the finer points of instruction execution on a real CPU, you must first comprehend how instructions and data are extract from memory. Real memory, like the little man computers' mailboxes, is made up of cells, each of which contain a single value and has a single address. Second, the memory address register and the memory data register are two registers that function as a connection between the CPU and memory. Some device manufacturers refers to the memory data register as the memory buffer register. Relationship between the MDR, DMAR, and memory. Ito po yung relationship niya. The memory unit cell each store 1 bit of data in figure 7.4. The cells are arranged in rows. Each row is made up of one more groups of bytes. Each row represents the data cells for one more consecutive memory addresses donated by the numbers 2 in the figure. Ito po yung kanyang picture. Ito naman yung MAR-MDR example. The memory data register is constructed in such a way that is effectively attached to each of the memory unit cells. Visual analogy from memory. Ito po yung visual analogy of memory. Ito siya. Saka ito yung picture. An individual memory cell. Ito naman po yung ibig sabihin ng an individual memory cell, saka yung picture. Memory capacity and addressing limitation. The 2-digit address space of each instruction determine the number of possible memory location in the Little-Man computer, which 100 different positions are addressed by the place counter, while is no such thing in a memory address register. The Little-Man is well aware that each memory location needs 2 digits larger location counter. Perhaps 3 digits would potentially allow the little man to fetch more instruction, but his data fetch and store are still confined to the 100 places that pre-address field in the instruction word will address. Similarly, there are two variables that decide the memory power of a computer. The number of bits in the memory address register determine how many different address locations can be decoded, such like a man computer's 2-digit addresses restricted the number of mailboxes to 100. The number of available memory addresses is m equals 2k for a memory address registered with a width of k bits. Primary memory characteristic and implementation. Memory is now distinguished by two key organizational forces as well as a host of technological aspects. The most critical memory feature in terms of operation is whether the memory is read-write capable of read-only. It just control is lost. Non-volatile memory preserves its values. It's non-volatile. The PET's executive instruction cycle. Ito po yung the PET's executive instruction cycle. Any machine functionality is based on the PET's execution instruction loop. This could seem to be bold assertion, but consider this. This computer function to follow instruction identical to those were already implemented. Ultimately, the key operation that can be done for register as stated in section 7.2 are moving data between registered, adding subtraction data to registered, shipping data within a register, and testing the value in register under certain conditions such as negative, positive, or zero. The PET's executive instruction cycle in CPU works similarly, as noted, much as the procedure consists of copying data from one register to another. You should always be aware that data copying does not affected from the registered, but it obviously replaces the previous data in the to registered with the new data being copied. Step in the execution of every instruction. Ito po yung mga steps niya na sa instruction. Doon lang po. Thank you.
Good morning, everyone. Our topic for today is all about classification of instruction. Most of the instruction in a computer perform some sort of operation on one or more source data values, which result in one or more destination data values. The operation may be a move or a load. It may be an addition or subtraction. It may be an input or output, or it may be one of many other operations that we have already discussed. Modern computers also provide instructions that the aid and the operation system software its work by providing security, controlling memory access, and performing other functions. Karamihan sa mga instruction ng ating computer gumaganap sa ilang uri ng operasyon ng isa o madaming source of data values na nagreresulta ng isa o marami pang destination data values and operation ay maaaring move or load, pwede ding addition or subtraction, or it may be input or output. Isa din ang modern computer na may instruction that aid operating system software. Gumagana ito by providing security and controlling memory access and performing other functions. Data movement instruction, load, store, and other moves. Because the move instructions are the most frequently used, and therefore the most basic to the computer designer try to provide a lot of flexibility in this instruction. Dahil ang move instruction, ito ang pinaka-common na gamitin, and therefore ito ang pinakamadaling gamitin sa computer. Arithmetic instruction. Every CPU instruction set includes integer, addition, and subtraction. Except for a few special purpose CPUs, every CPU today also provides instruction for integer, multiplication, and division. Many instruction sets provide integer arithmetic for several different word sizes. As with the move instruction, they may be several different integers arithmetic instruction format providing various combinations of register and memory access in different addressing modes. Ito ang pinaka-modern. Ito ay nag-provide ng instruction by performing Boolean algebra. Arithmetic instruction. Dito pumapasok ang mga salitang addition, multiplication, subtraction, and division. Boolean logic instruction. Most modern instruction sets provide instruction for performing Boolean algebra. Commonly included are a NOT instruction which inverts the bytes on a single operand, as well as AND, exclusive or instruction which require two resources, arguments, and destination. Ito ang pinaka-modern. Ito ang nagpo-provide ng instruction by performing Boolean algebra. Single operand manipulation instruction. In addition to the NOT instruction described in the previous paragraph, most computers provide other convenient single operand instruction. Most of these instructions operate on the value in a register, but some instruction sets provide similar operation on memory values as well. Karamihan sa mga instruction na to ay gumagana by operate on the value in a register, pero ang iba ay nagpo-provide ng similar operation on memory values. Next. Byte manipulation instruction. Most instruction sets provide instruction for setting and resetting individual bytes in a data word. Some instruction sets also provide instruction for operating on multiple bytes at once. Karamihan sa instruction na ito ay nagpo-provide ng instruction for settings and resetting individual bytes in a data word.